Assalamualaikum everyone. Today we are having one of the important syntheses which is included in heterocyclic course, which is pyrrole synthesis. Here I have drawn the structure of pyrrole. You can see this. It is actually a 5-membered ring compound, like 1, 2, 3, 4 and 5. 5-membered heterocyclic compound because a heteroatom nitrogen is attached here. Okay, the synthesis which I am going to explain in this video is 4+1 approach. It means that a 4-carbon containing compound is going to be react with ammonia to give us pyrrole, the required product. 1,4-diketones are being used in this synthesis. Now you can observe that I have written the strategy reaction scheme here. But the question arises how this reaction proceeds. So for that we have to look for the mechanism. Now have a look over the mechanism. Here we have NH3. We know that NH3 having the lone pair. These lone pairs are going to attack over this electrophilic center of carbon atom. As a result, the bond between the oxygen and the carbon atom is going to be break, and in the next step what we are getting, we are having an oxygen atom with a negative charge and nitrogen atom with a positive charge. The reason behind this is that we know whenever oxygen forms less than 2 bonds, a negative sign is created onto the oxygen, showing a deficiency of a bond. If we are making 3 bonds with oxygen, then a positive sign is created. Okay, now here look at the nitrogen. As nitrogen commonly made 3 bonds, as it has a 3 valency, but when it is attacking over this electrophilic center and attached over this position, then it is making 4 bonds. Therefore, a positive charge is created. Afterwards, in the next step, what is happening? Minus hydrogen and positive hydrogen. It means that hydrogen transfer occurring in this step. This hydrogen is being transferred from nitrogen atom to the oxygen atom. As a result, here we are getting the product. Okay. Now you can see that again the 3 bonds are making with nitrogen, so it has lone pair electrons. They can again attack over that electrophilic center. The same procedure is going to be repeat as in this step. Remember one thing, that nitrogen lone pair are going to attack 2 times. One time here and second time here. Okay, in step number 3 and in step number 1. Now have a look here. What is going to be happen? This is actually a cyclization step. The cycle is going to be formed. This lone pair is going to attack over there, and in the same manner this bond with oxygen and carbon is going to be break up. Afterwards the same process is going to be repeating, deprotonation and protonation, or we can say that the transfer of proton from one atom to another atom, from nitrogen to oxygen, okay, for removing or for neutralizing the charges. Afterwards we are having this kind of a species. Here we have OH and OH. Now the bond from the hydrogen is going to be shift down and water is eliminating. And in the end, eventually we are getting the product, the required product, or the product we are going to synthesis in this video. Okay. I want to explain the last step which I have shown there. You all seen here that I have eliminated water from this side. Actually we know very well that hydroxyl group is a bad leaving group. It cannot leave quite easily. Therefore, first of all the protonation take place, and then this hydrogen is going to shift its bond here, and then the water is going to be eliminated out. As a result, a double bond on this position and on this position is created, and we are having the main product pyrrole. And that was all about pyrrole synthesis. Pyrrole synthesis or 4+1 synthesis is also called as Pal-Cannor synthesis.